Okay, in this video, we're going to talk about how to solve polynomial equations. So we spent quite a bit of time learning how to factor polynomials, and now we're going to put that factoring to good use. So now that we know the basics of factoring polynomials, one of the things you can do with that skill is solve polynomial equations. So we're going to take a look at how to solve certain polynomial equations, not all polynomial equations, but certain ones. And basically, the main thing we're going to use is what's called the zero product property. So we're going to use this little fact over and over again when we solve polynomial equations. So basically, it says that the product of two or more real numbers is zero if and only if at least one of the factors is zero. So what that's saying is when you multiply numbers together, the only way that you can multiply them together and get an answer or product of zero is if one of the numbers you were multiplying with is zero itself. So in other words, if you take a number A times a number B and you get an answer of zero, the only way that could happen is if A was zero or B was zero. One or the other has got to be zero. That's the only way you're going to multiply them together and get zero. So with that little fact, that's and our factoring that we've now been practicing for a while, with those two things, we can now solve polynomial equations. So for example, let's solve x minus 5 times x plus 2 equals 0. So this is a polynomial. If I multiply this out, I'll get an x squared, a 2x, a negative 5x, and a negative 10. That's a polynomial. But in this case, I have an equation. So I've got this equation with x in it, and I want to solve for x. I want to figure out what x is. Well, we're just going to use the zero product property, which basically says if this number times this number is zero, then one of those has to be zero. So this is just some number right here. This is some number that we don't know what it is. I know there's an x in it, but remember, x is just holding the place of some number that we don't know. So this will be some number minus 5. Well, if you take a number minus 5, you just get another number. So both of these are just numbers, real numbers. So this number times this number will be 0. Well, the only way that's going to happen is if x minus 5 is 0 or if x plus 2 is 0. That's the only way this equation is going to be true. So if we add 5 to the other side, x has to be 5, or if we subtract 2 from both sides, x has to be negative 2. So our solution set, so remember this is an equation, so our answer is written as a set. Our solution set is the set of all x such that x is equal to 5 or negative 2. Okay, so let's check and see if that really does work. So let's try x equals negative 5. So let's do that one first. So or x equals positive 5, sorry. So let's plug in 5 for x. And we get 0 times 7 is 0. Well, that's true. So x equals 5 is definitely a solution. Well, let's check x equals negative 2. So let's plug in negative 2 and see what we get. So we get negative 7 times 0 is 0. That's true. So both of those are solutions. 5 and negative 2 are both values of x that make that a true statement. All right, so let's try another one. So here's another equation that involves a polynomial. So x squared is a polynomial, x plus 30 is a polynomial, and we have an equal sign, so this is an equation. And we want to figure out what values of x will make this a true statement. So what we're going to do is we're going to move everything to one side. And the reason we want to do that is if you go back and look at the previous example, it was x minus 5 times x plus 2 equals 0. So it was this factor times this factor equals 0. So this was factored, and then we just set each factor equal to 0 to see what values of x we wanted. Well, if you look at this example, it's not factored. So x squared, x plus 30, if you put it all on one side, it's not factored. So we're not quite ready to use the zero product property. So the first thing we're going to want to do is factor that polynomial. That's why we spent so much time learning how to factor. It's one of the reasons. So factors of 30 that differ by 1, we'll have 6 and 5. And if we get a negative 6 plus 5, we'll get the negative 1. So now it's factored, and x minus 6 has to be 0, or x plus 5 has to be 0. One or the other has got to end up being 0. So if we add 6 to both sides, we get 6. If we subtract 5 from both sides, we get negative 5. So our solution set will be the set of all x such that x is equal to 6 or negative 5, one or the other. So let's check our answer. Let's make sure that's correct. So let's do x equals 6 first. Let's plug that in. So it'd be 6 squared equals 6 plus 30. It's definitely a true statement. It's 36 equals 36. Let's check negative 5. So negative 5 squared equals negative 5 plus 30. Well, that's 25 equals 25. That's true. So both of those are solutions for that equation. So this example shows you know, is typically what's going to happen. You're going to have a polynomial equation. You'll need to move everything to one side, factor that polynomial using any of the stuff we've talked about with factoring, and then set each factor equal to 0 using the zero product property, and figure out what those x values are. All right, a little bit of vocab. So when you solve a polynomial equation in one variable, so if you go back and look, our polynomials only had one variable. So this just uses x's, this one just uses x's. So there wasn't x's and y's or x's and z's or anything like that. It's just one variable. So when you find solutions to polynomial equations in one variable, those solutions are also called roots. So when you hear the word root, we're talking about the solution to a polynomial equation. So if you go back, these are called roots. So x equals 6 and x equals negative 5, those are roots for that polynomial equation. Same thing here. X equals 5 and negative 2, those are roots for that polynomial equation. Well, if you have a polynomial function, so remember functions have two variables, usually x and y, but they don't have to be x and y, they can be any two variables. But if you have a polynomial function with two variables, and functions, one of the things we like to do with functions is graph the function and see where all its solutions are. And when we graph, we like to find x and y intercepts. Well, it turns out when you find the x-intercepts to a polynomial function, that would be when you're finding x-intercepts, that's when you plug in 0 for y and solve. So that was one of the things we talked about at the beginning of the year. If you want x-intercepts for any function, you just plug 0 in for y and solve. Well, when you do that for a polynomial function, when you plug 0 in for y and solve for x, the answers you get are called zeros. So a little bit of vocab here. Roots are the answers to polynomial equations. Zeros are what we call the x values where y equals 0. In other words, the x-intercepts. So a 0 is another word for x-intercept. So zeros and x-intercepts are the same thing. So for polynomial functions, the x values for which y equals 0 are called zeros. And that's just a fancy word for x-intercept. So let's look at this next example. So we need to find the zeros of this function. So notice we have a y and an x. We have two variables. So this is a function, and we want to find the zeros of the function. So to do this, we just have to remember that zeros are the same thing as x-intercepts. They're the same thing. So what that tells me to do is set y equal to 0 and solve. That's how we always find x-intercepts. So let's do that. So let's plug 0 in for y. Don't forget, f of x is just y. That's just another way to write y. Okay, so on the right-hand side, we have a polynomial. But notice it's not factored because we have x minus 4 to the third minus 4 times 3x minus 16. So it's not factored. We need to factor it. Well, right now it doesn't have a greatest common factor. It's not a special product. I mean, the way it sits, I don't know how to factor it. So we're going to have to kind of mess with how it looks so we can factor this thing. So let's go ahead and cube that binomial. So it'll be x minus 4, x minus 4, x minus 4. And let's distribute the negative 4. So it'll be minus 12x plus 64. And then let's multiply that out. So we're going to get x squared minus 8x plus 16 times x minus 4 minus 12x plus 64. And then now we got to take this trinomial times this binomial. So we're going to get x cubed minus 4x squared, then minus 8x squared plus 32x plus 16x minus 64 minus 12x plus 64. Now we're going to have some like terms. So those are like terms, and then we're also going to have those are like terms, and then terms. So we got all kinds of like terms there. So we have x cubed, and then we have minus 12x squared, and then let's see, that'll be 48 minus 12 will be 36x, and then negative 64 plus 64 is 0. So now we're left with a polynomial that we do know how to factor. So if you look, x cubed, x squared, and x, everything has an x in common, so the greatest common factor is x. That leaves us x squared minus 12x plus 36. And then x squared minus 12x plus 36 is a perfect square trinomial. So that'll factor into, let's see, x minus 6, x minus 6. So that should work. X squared minus 6x is minus 12, and then negative negative is positive. So that should work. So now it is factored, so we're going to use the zero product property. So x is equal to 0, or x minus 6 is equal to 0, or x minus 6 is equal to 0. So x is equal to 6, x is equal to 6. So we got 3 solutions there. So our zeros are 0 and then 6. Now notice that 6 showed up twice. You don't have to write it twice, but you do want to make note that it showed up twice. So we would put 6, and then just you want to write down that that was, we call that a double 0. And if there would have been 3 of them, we would have called it a triple 0. Something like that. So we just want to write down that that showed up twice. And so there's our There's our zeros for that function. So don't forget, uh, zeros are the same thing as x-intercepts. So um, what this also tells me, that the x-intercepts for the graph of f are 0, 0, and 6, 0. So if we did graph it, we would know that the graph is going to cross the x-axis at 0 and 6. So zeros and x-intercepts are the same thing. You find them the exact same way. Plug in 0 for y and solve. Okay. Let's do a story problem that involves a polynomial equation. So let's say we have a poster, and like a poster you would hang on your wall, that kind of poster. And let's say it's to consist of a rectangular design with a 3-inch rectangular border around it. So we've got this rectangular poster, and it's supposed to have a design in the middle of it, and around it's supposed to be a 3-inch border. So they're just telling you that from here to here is supposed to be 3 inches. So let me draw this bigger so I can label everything a little bit easier. Draw my poster a little bigger here. Alright, so they're just telling you that the border is supposed to be 3 inches. So from here to here, that's supposed to be 3 inches. And then from here to here, it's supposed to be 3 inches, all the way around. The design is to be twice as tall as it is wide. So however wide this is, it's supposed to be twice as tall. So that needs to be 2w. So this is where it's going. It's right. The design on the poster is going. It's right there, that rectangle. And it says the area of the poster is to be 680 square inches, and to find the dimensions. Okay, so let's look at our poster and see what we got here. The area is 680 square inches. And we know that area is equal to the width times the height. So the width of the entire poster, well, the width of the design is just W, but on either side, we've got 3 inches. So all the way across this entire thing, so the entire way across will be W plus 6. So it'll be this 3 inches right here, this 3 inches right here, and then this W. So it'll be W plus 3 plus 3. So be W plus 6. And then how tall the poster is, well, it's 2W is for the design, and then this is 3 inches and this is 3 inches. So it'll be 2W plus 6. So how wide the poster is and how tall the poster is, when you multiply those together, it should give you the area, which is 680. So we end up with a polynomial equation. So this is a polynomial, this is a polynomial, and we got an equal sign, so it's a polynomial equation. But right now, the right-hand side is factored, but the right-hand side equals 680. So we can't use the zero product property because we need this to equal 0. So what we're going to have to do is multiply these together, then subtract 680 from both sides. Which would be negative 644. And then let's factor the right-hand side. So let's take a 2 out of both of them. And then w squared plus 9w minus 322. Let's see if we can't get that to factor. So 322 is 14 times 23. And we need a positive 9, so that have to be plus, that have to be minus. So we end up with w minus 14 equals 0, or w plus 23 equals 0. So w is 14, or w is negative 23. Well, w was how wide the design is, so you can't have a negative width. That doesn't make any sense. So 14 inches will be the width of the design. So the design in the middle of the poster is going to have a width of 14 inches and a height. So the height is supposed to be twice as tall, so it'll be 28 inches. 28 inches. So sometimes to model a certain real world situation, we'll end up with a polynomial equation, and then when we solve that, we can find out some things about that particular situation. In this case, we had a poster. So the basic idea throughout all of this is get everything on one side, factor that side, and set each factor equal to 0 using the zero product property.